Section 9.1 is on solving systems by graphing. Now, all of Chapter 9 is going to be solving systems. Remember, systems are a group of two or more equations. So to solve those, what we're doing is we're trying to find two unknowns instead of just one. So the first thing that we will do is this. The first types of problems I will give you are, I will give you a system of equations, and that's what this is right here, is just two equations with two unknowns. And I'm going to say, is this, negative 1, 6, is this a solution to this system of equations? And so in order to determine if this is a solution to the whole system, it's got to make this x and this y has to make both equations true. So in order to check that, you simply plug in the x and the y from the answer I've given you into both equations. And if both equations then are true, then it is a solution. And if either or both of them are not, then it's not a solution. Let me show you what I mean. So x plus y equals 5 and y equals 2x minus 4. And I want to know, is negative 1, 6 a solution to this system? So what you would do is first, you're going to take the negative 1, 6 and you're going to put it into the first equation. So negative 1, that's your x, plus 6 is your y, equals 5, and you say, is it? Well, negative 1 plus 6 is the same as 6 minus 1, and that does equal 5. So that one is true. So then you flip down, okay, well, if that's true, then so far so good. Now we got to check the second one. So y equals 2x minus 4, so y is the 6. Make sure you put the correct number in for the correct variable. All right, so the x always comes first, the y always comes second. So the 6 is the y. 6 equals 2 times x, which is negative 1, minus 4. And we want to know, that's a question mark, is this equal? So 2 times a negative 1 is negative 2. Negative 2 minus 4 is actually negative 6. So does 6 equal negative 6? No, it does not. So this is not a solution. All right, so let's check the other one. So do you see that it does make this one true, but that doesn't make it a solution? It's a solution to this equation, but not to the system of equations. Because remember, a system is two or more equations. Okay, here we go. So let's try 3, 2. If you think you know what you're doing, you probably do. Go for it. See if you can beat me. All right, so I just messed that all up. Okay, so x plus y equals 5. 3 is x, 2 is y. Does that equal 5? 3 plus 2 is 5. Yes, it does. And then 2 is the y equals 2 times 3 is the x minus 4. Does that equal this? 2 times 3 is 6 minus 4. 2 equals 2. Yes, it is. So this 3, 2 is a solution to this equation, or to this system of equations. Now, a system of equations is, and in this case, if you have an x and a y, both equations are a line. So the solution to that system is going to be a point, because either that line is going to cross at one point, or, here, let me show you, and I'm going to actually, this is what you're going to be doing in the last part of your homework. You're going to classify the systems of equations. So when you'll actually get a graph, and you'll classify that graph. A consistent system has a solution. You can either, to be a consistent system, either one line goes whatever way, this way, and the other line goes this way, and there's a place where they meet. That place where they meet is the solution, and this graph has one solution, and it is consistent. You could also have a graph where the first line is the first equation is this one, and then if you graph the second equation, sometimes even if it looks like the same thing, maybe it's just multiplied by something, and when you graph it, you actually get, if you can draw, you get the same line. And this isn't a curvy line, this really is a straight line. So you can also get the same line. So if two equations are exactly the same line, then it's still a consistent graph. And in this case, you have infinite solutions. I-N-F-I-N-I-T-E, solutions. Now, this isn't the same as all real numbers. It's not all real numbers. You do have an infinite number of solutions, and all of the numbers are all of the points that are along that line. Okay, so your answer is consistent and infinite solutions. It's all of the solutions to that specific line. All right, that's not the same as all real numbers, and not every number on this graph is a solution, just the ones that are on that line. All right, and a graph can be inconsistent if there is no solution, and the way that happens is if you've got two lines that are parallel. If the two lines are parallel, they're never going to cross. They're never going to meet. And a solution is where both of those lines are in the same place at the same time. All right? So you can either have one solution, infinite solutions, or no solution. If there is a solution, either one or infinite, then that's consistent. If there's no solution at all, that's inconsistent. You're going to want that in your notes. The last several questions on your homework. Simply say classify these. Okay, so the reason I did that was in order to solve a system of equations, we're trying to find where is that point of intersection. And normally there is a point of intersection. Not all the time. We've got the other two options also. But here are your steps. In order to find, and now we're going to discover other ways to solve systems in the week, but right now, we're going to solve, and if we're solving by graphing, here's what we're going to do. Step 1, you're going to graph both equations on the same graph. Step 2, you're going to look for where the point where they cross, that's the solution you're looking for. Now, be sure you're doing this homework on graph paper, please. Because if you don't, then it's sometime, I mean, you've seen me try to graph without the graph paper. Some of the lines aren't quite the same distance apart. If you're trying to find a solution, you're trying to find a point, you need to have that on graph paper, and you need to count, you need to use a ruler so that you've got straight lines so that you know where that point is, okay? Now, if you'll remember, I'm going to just remind you, and you might want to write this in your notes, there are two different ways to graph lines. All right, the first way, if you'll remember, is to use the y equals mx plus b form. That simply means you're going to solve for y. Isolate your y, get it by yourself. Get it by itself. What's left then is mx plus b, where m is your slope and b is the y-intercept. Hopefully you remember this. We've done this before. So then once you get it into this format, you're simply going to plot the y-intercept and then use the slope to find a second point. All right, get this in your notes because I'm going to take it away and I'm going to do one, okay? So have this in your notes so that you can refer back. Another way to graph is to put 0 in for the x and find the y-intercept, and then put 0 in for the y and find the x-intercept. So that will tell you where your line crosses the y-axis and then where it crosses the x-axis, and then once you've got those 2 points plotted, then you can make your line, you can draw your line from those 2 points, okay? You got this in your notes. If you don't, pause it, get it all the way in your notes, and let's do some. All right? We've got two systems that we're going to graph, and I have my lovely graph paper here. Ta-da! Makes my eyes go wiggy, but that's okay. Here we go. So what we're going to do is, let's go ahead and graph the one that we already solved, or we didn't solve it. I gave you the solution and you found out what it was. So on this, we've got two different, you can decide if you want to use the y equals mx plus b form, or if you want to use the intercept form. Both ways will work on all equations. A hint is, if it's already equal to y, I would use the y equals mx plus b form for this one. This one, you can choose. If you want to subtract x, and there you go, it's y equals mx plus b, do it that way. If you'd rather put your zeros in, let's show you how to do it. What you're going to do there is, you're going to say, well, x plus y equals 5. If you put in 0 for the x, now y equals 5. So your y-axis, your y-intercept is 1, 2, 3, 4, 5. There's a point there. And if you put in 0 for y, if you put in 0 here, now x equals 5. And remember, I think I've showed you before, on your paper you can just cover it up. So now x equals 5. Okay, so x equals 1, 2, 3, 4, 5. There we go. And you know what? I should have had a straight edge of some sort. Here's a lovely piece of paper. I don't think this is going to be firm enough. This is not going to work. Oh, this is just going to be lovely. Oh, wow. Oh, it worked. It worked. Nice. Okay. Now, with this one, with this equation, I'm going to use the y equals mx plus b because it's already set equal to y. So, my y-intercept is -4, so that means on the y-axis, I'm going to go down 1, 2, 3, 4 and plot a point. And my slope is 2, so that means from the point that I already plotted, I'm going to go up 2 over 1. And if you want to do 2 of them, just to make sure that you've got a straight line, and then there's your line. And now you can see this is your solution here where they cross. And so then you say, well, what point is this? From the origin, this is 1, 2, 3 over, 1, 2 up. So 3, here, I'll write up here where you can see it. 3, 2 is your solution. And that actually is what we already discovered when I gave you the answer. All right, but you can see that this -1, 6 isn't going to be anywhere near this other line. All right, so let's do another one. Get yourself a piece of graph paper real quick while I'm erasing, and you start graphing these two. Let's see if you can do it faster than I can. All right, the first one is already in y equals mx plus b format, so you know that the y-intercept is going to be the 1. So you're going to go up 1, and you have your first point already. Your slope is -3. Now, negative means you're going to go down. You always go to the right, but the negative and positive tells you whether to go up or down. So you're going to go down 3, 1, 2, 3, over 1, and there's your first line. Oh my goodness, I'm going to need to get a big long ruler. That would be more fun than this. Oh my goodness. Okay, there we go. I don't know where the answer is, so I don't know how far to go. All right. So now with this one, you can either add the y to both sides and subtract the 4, and then you've got a y equals mx plus b, or you can put in 0 for the x, and now y equals, now this would, if you put 0 in for x, now you've got -y equals 4, so you'll need to divide by the -1. So to get just the y equals -4. Did you see what I did there? So y is -4, so there's my origin, 1, 2, 3, 4. So there's 1 point. And now for your x-axis, or for your x-intercept, you're going to put in 0 for the y. So now 2x equals 4. So to get the x by itself, you got to divide by 2. So x, the x-intercept, is 2. So along the x-axis, so along the right and left, you're going to go 1, 2 over and plot a point there. So once you've plotted at least 2 points on a line, then you've got yourself a line. And we can see that where they cross, because I'm using graph paper, use it, we can see they cross right there. And that is the point 1, 1, 2 down. So 1, -2 is your solution. So not only do you need to circle it on your graph, but then you need to determine what point that is. So then next to, when you're writing your system out on your paper, then you write out, you circle it on your graph, but then you also put the solution as 1, -2. That's what I want to see. I want to see that, and I want to see your graph. All right. I think that's all we have to do. You can do this. So step 1 is to plug in an answer that I give you. And remember, it has to be true for both equations in order to be a solution. And then step 2 is to actually graph several of them. You can so do this. All right, you've got 2 ways to do it. Either put it in y equals mx plus b form, or put in 0 for the x to get your y-intercept, and then 0 for the y to get your x-intercept. Graph them and find your solution. And then the last section, remember, is classifying. Is it consistent? Does it have an answer? Is it inconsistent? Doesn't have an answer. That's it. I'll see you next time.